Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT or troubleshooting course, and this afternoon's video tutorial is going to be on Challenge Activity 1, the SECHNIK use case, or one of the SECHNIK incorporated use cases here. And you can see that this is the topology that we've been presented with. So let's take a look at our scenario. We're going to tackle each of these in turn. So right out of the gate, we see that we get to work on Monday. We've got 4 trouble tickets that we're going to be working with here. So the first one, Kimberly, the user on PC1 cannot access data on the server at 172.16.210. And so this is the server right up here, that 172.16.210. So we'll start with this ticket first. Now remember, we've got a wide range of options, right, in terms of structured approaches that we can take. We can go from the bottom-up approach, divide and conquer, follow the path, some that we can eliminate right away because we know that we're in a simulator here, would be the rip and replace, right, of removing the equipment. We can even do spot the differences, or the compare and contrast approach. But again, the move the problem approach might be a little, it's not going to happen here because obviously we have no control over the physical links that are set up. This topology is sort of hard-coded in. So let's go ahead and Kimberly again, and I actually already forgot, what PC would she say she was on? PC1, and she's trying to get to 172.16, and let me write that down, 172.16.200.10. So one of the quickest things that we can do is to sort of do the divide and conquer, right? So we pick a layer of the OSI model and we try to determine is the issue at that layer, above that layer, or below that layer, right? So ping is typically one of the first commands that gets used, right? So if we were to ping 172.16.200.10, we get this message here: unrecognized host or address or protocol is not running. So if ping, which relies on layer 3 addressing, right, that IP address, if that's not working, typically the issue 99% of the time is going to be below layer 3, right? And so this is where we get to pull in a lot of the commands that we would look at for a layer 2 issue, or what could be a layer 2 issue. So again, on the PC here, let's say show IP interface brief, right? We want to see what the interface looks like, and specifically that status and the protocol. So key thing to remember here is that when we look at that show IP interface brief, remember that status is giving me layer 1 information, right? And so when we see up here, that's telling me that, yeah, we have a physical cable that's plugged in and we've got link, right? So there is a successful link there. When we talk about protocol, we're talking about layer 2 protocol. And we're on, this is this really isn't a PC, it's a Cisco router that's being set up to act like a PC, but where this will come into play, the protocol at layer 2, where you could see up, down, is when we talk about serial links, right? When we have PPP encapsulation on one side but HDLC on the other, or HDLC on one side and PPP on the other, right? And that's typically where you're going to start to run into an up layer 1 connection where the serial cable's plugged in and the device recognizes that, and then the protocol is down because you've got a mismatch on your in cap for those devices. But again, that show IP interface brief, now that we know that we've got an issue here below layer 3, we can start taking a look at that layer 1 and layer 2 information. Now, we also see some key output here that the method to get an address is DHCP, yet we have no layer 3 address. Again, a clear indicator that we've got some sort of layer 2 issue. So could it be, and again, the layer 2 issues that we've talked about, you've got VLAN issues, you've got trunk issues, we've got, maybe there's a VACL VLAN ACL that could be involved, right? So we've got maybe there's a problem with the MAC address table of some kind. So remember we talked in class about after you run the ping command, right? If you don't get anything back, one of the things that you want to check on is let's take a look at that MAC address table. So this is a very good command, and remember it's show MAC address. Whoops, address. Let me make sure. Actually, is it going to be show MAC? They want address, like they want MAC dash address. Or are they not going to let me run that command at all on here? Yeah, interesting. So there is, I guess on the PC, it looks like they've pulled that command away from us on the PC. So let's go ahead and continue on. We know that the interface shows IP interface brief. We see the interface shows up. So layer 1 is good, which means we've got link. Layer 2 is good, which means the encapsulation, right, Ethernet, is good. So now we come take a look here, and we've looked at the PC. So now let's step up here to the switch into which the PC's plugged in, this access layer switch 1. Because if we're up here and we show that we need to get a DHCP address, but we're not, that means we're going to move up the food chain, right? And we're going to take a look at the next component, right? And so this might be sort of follow the path. We started with a divide and conquer. Now we're taking a look at following the path, right? So now we go to the next device. We get into privilege exec mode. And let's go ahead and say show IP interface brief. And just a quick look here, you can see that all the interfaces are showing up. So I'm not sure what interface the PC's plugged into. And let's take a look here. It looks like they've got some notes. Some descriptions have been put in here, right? Remember, we talked about the importance of the description, but the description is only as good as the individual who entered it in. So to make sure that this is correct, how could we do that? Well, let's go into global config interface Ethernet 01, and I'm going to say shut. So we'll shut the interface down. So if I come back over here to PC1 and say show IP interface brief, so we still show up, right? So we've got layer 1 and layer 2 is good, but should that be the case, if I shut down the port, should we be seeing up? And did I do the correct interface? PC1, I did, so it's administratively down. Let's make sure, do show IP interface brief. Yep, so it's administratively down, but we still see up over here, right? Which means, and I don't think that that's what you're supposed to see. So in a real quick way to check that is, and again, we're in a simulator here, so that's okay, but let's take a look, right? We've got, what do we have plugged in here? I've got a MacBook, I think, plugged in here. Let's see if we should get FA. Yeah. So on interface fast Ethernet 103, if the interface gets shut down, we should not see a link on the other side. And so let's get into global config interface fast Ethernet 103. If I say shut, say do show IP interface brief, right? You can see that 103 is administratively down, and when you take a look at the actual device and don't have that up, it comes back and it says Ethernet not connected, right? So the actual MacBook is saying, hey, I am no longer connected. And you can see that here. Let me pull that up real quick. Didn't anticipate turning around and pulling that up, but when we saw that behavior there from the, and let's get the password in here. Yeah, you can see that the interface was shut down, so it shows not connected because the interface is administratively down. If I bring that interface back up, if we say no shut, take a look, right? We just simply come up and we're trying to do a DHCP address and it says no address, but it goes from not sensing the connection to sensing the connection. So typically what you would see is that the link is going to show down. So how else could we approach this? Well, what I could try to do is say no shut. We'll bring that interface up. Let's get into the interface on the PC. We'll go into global config interface Ethernet 00 and shut this interface down. Right? So from the PC side, we're going to shut things down. Do show IP interface brief. So we're definitely administratively down. And again, we're doing this to confirm that that is plugged in correctly. So again, it shows up, up. Realistically, you're not going to see up, up. So we'll say no shut, bring that interface back up, and we'll continue. We'll go ahead and assume that the comment is correct. We have our job aids as well. But again, diagrams are only as good as the last update of the diagram. And so you can see here Ethernet 00 and Ethernet 01. Any other information? We say interface VLAN 10 and VLAN 20. All right, so PC1 should be in VLAN 10. So here we are back on PC1. The interface is up, show IP interface brief. So we're up, up there. The switch here is up, up, do show IP interface brief. So now we know we're supposed to be in VLAN 10. So let's say do show run interface Ethernet 01. Let's take a look at the port into which the PC is plugged, right? So again, we're still kind of focusing on the layer 2 aspect of these connections because, again, we have no IP address. We don't have layer 3 functioning. So switch port access VLAN 10, that looks good. Switch port mode access, that looks good. Spanning tree port fast, no problem. Duplex auto. So from a port perspective, everything looks good. Let's say do show VLAN. Right? We can see that VLAN 10 is not shut down. It's active. And Ethernet 01 is a member of VLAN 10. So everything looks good here from that perspective. What about do show interfaces trunk? So we'll take a look at the trunk link that runs between this access layer 1 switch and the DSW1 switch. So one of the first things that you want to look at, you want to check and see which interfaces are in the trunking mode. You want to look at the encapsulation. Right? What's the native VLAN set to? If we had a native VLAN mismatch, we would be seeing errors streaming to the screen here. And the encapsulation, right? 802.1q. So everything looks good here with the exception of what? What VLAN is PC1 in? Exactly. PC1 is in VLAN 10. So it looks like we may have discovered a problem here. Now we're looking at this and I clearly see that VLANs in the spanning tree forwarding state and not pruned are VLAN 1 and 20. If I say do show spanning tree, what do we see? So there's VLAN 1 and we see all the forwarding designated ports and the forwarding ports. We see VLAN 10, right? And it shows that for spanning tree Ethernet 01, right? But is that the trunk link? No, remember, that's not the trunk link. Ethernet 01 isn't the trunk link. And then for VLAN 20, we've got Ethernet 00. And remember, that is our trunk link. Do show interface trunk. Ethernet 00 is the trunk. 01 is not the trunk. That's the port that's facing our PC. So from here, we can now do a spot the differences approach maybe, because we look at our topology and we see, okay, ASW1 is set up like that. Well, what does ASW2 look like? What is it showing? Show interface trunk. So now we do this compare and contrast or spot the differences approach, and what do we see? Exactly. We see that over here, VLANs 1, 10, and 20 are allowed. When we look at ASW1, and I say do show interfaces trunk, we're missing VLAN 10. So why would we be missing VLAN 10? Well, let's hang out at layer 2 here. Let's take a look at the trunk link itself, the interface that is set up as a trunk link. And let's say do show run interface Ethernet 00. I come down and look, I see description link to DS1, trunk encap.1q, we're good there. Switch port mode trunk, we're good there. And then allowed VLANs 1 and 20. Come over here and let's take a look at the trunk link here and say show run interface Ethernet 00. And it should jump out at you immediately, right, that we've got a layer 2 issue here, that VLAN 10 is not being allowed across the trunk link from the access layer switch to the distribution layer switch. So before we make the change, let's take a look at that distribution layer switch. And let's say show interfaces trunk. We should see 2 interfaces, right? 01 and 02. One goes to ASW1 and the other goes to ASW2. So when we look here, and we see on this side of the trunk link, VLANs in the spanning tree forwarding state and not pruned, everything looks good over here. In fact, we could quickly do a compare and contrast, show run interface Ethernet 01, right? So the trunk, the VLANs are being allowed, show run interface Ethernet 02, and all of the VLANs are being allowed. So we've isolated the issue here to the VLAN not being allowed. So let's get into interface Ethernet 00 and let's resolve this problem. So switch port trunk allowed VLAN 10, and that's not what we want. I want switch port trunk, and we're going to add it in there. Allowed, and is it going to force me to, there we go, add. So VLAN add. Now remember, if I were to say switch port trunk allowed VLAN 10 and hit enter, watch what happens. Do show interface trunk. Now what did we do? And we're going to let spanning tree reconverge here. So we should say, see that bottom line here, this VLANs in the spanning tree forwarding state and not pruned, we should be seeing 10 here, and I'm hoping that it's not going to make us wait. Do show run interface Ethernet 01. Yeah, so switch, did I say switch port access? Oh, I'm sorry, looking at the wrong port, Ethernet 00. I was like, hold on a second there. So yeah, so only VLAN 10, do show interface trunk, only, and there we go. So spanning tree reconverged, and now it's only VLAN 10, because remember, the command that I entered here was switch port trunk allowed VLAN 10. So this is not additive by default. By default, this is simply going to rip and replace whatever the previous allowed statement was and put that statement in. In order to add it, and that's why I was backing up VLAN, we would want to say add, and at this point we don't want to add 10, right? We want to add 1, and 20. And let's see, did that do what we would anticipate it was going to do? Do show run interface Ethernet 00, and it did. So now this looks like, again, when we started with the divide and conquer, and then we kind of transitioned into a bottom-up approach, right? We dropped ourselves down to layer 1, layer 2 to see how that was, what that was going to look like, and then we use compare and contrast to take a look at, well, how are the other switches set up? And then we were able to confirm our hypothesis that, hey, VLAN 10 is missing from this trunk port. And so that's how you can use the different approaches, you know, as sort of a blended way of approaching things, right? Quickly divide and conquer, roll down to the level we think, or roll down to the layer we think the problem is going to be at. So now let's go ahead and take a look here at PC1. Aha! And take a look at what happened. So while we were troubleshooting and discussing how we approached it, DHCP address has been assigned. So let's take a look now. So let's say show IP interface brief. So now PC1 picked up a DHCP address. Again, we're in an up state. So can we ping 172.16, and I'm glad I wrote this down, I would have forgotten it, 172.16.200.10, and take a look at that. We've got success. So by sort of blending the approaches, right, and sticking with a process, and I can't stress this enough, that you should have a process and you should follow that process and make sure that you're following that process. All right, so it looks like we've got connectivity here to the server, so that trouble ticket has been taken care of. So let's talk about the next trouble ticket. So Andrew, he's on PC2. He cannot access the internet, and I'm going to write this address down as well so I don't forget, 209.165.200.2. So again, let's see what's going on. If you were to go from a top-down approach, you may go over to Andrew's desk if he's in the same office building that you're in and say, you know, pull your browser up and show me, can you connect to google.com? Can you get to cnn.com? Maybe start from the application layer and work your way down, right? But we don't have access to any applications on his PC. We have access to his PC. So here we are on PC2. Let's say show IP interface brief. Now remember, we're in VLAN 20 here, and this is interesting because he has an IP address. So we can see that layer 3 appears to be working because we've picked up, or layer 2 was good enough to get us the IP address. So we have a layer 3 address. Let's right out of the gate. So he says he can't access this IP address. Let's check. Can I ping that IP address? Okay, so I can't ping the IP address, so the issue typically would be something below layer 3, which leaves us with layer 1 and layer 2. But let's see, I can't ping all the way out to the internet, but I can still use ping to see, can I ping my default gateway? Let's take a look at DSW1 here and say show IP interface brief. And you can see that VLAN 20 has an IP address, right? And this is the default gateway address for VLAN 20, which is 192.168.20.1. So from PC2, can I get to my default gateway at least? Because if I can't get to that default gateway, and this is also sort of your divide and conquer approach, if I can't even get to the VLAN here to ping that switch virtual interface, the SVI for VLAN 20, then chances are my problem is below this level. Because if I can't ping VLAN 20 here, then maybe it's a trunk link issue here. Maybe, I'm sorry, I'm actually on the wrong side there. Maybe it's a trunk link issue here. Maybe there's a trunk link issue here. It could be, you know, we picked up the DHCP address, so chances are it's not our access interface, but it could be something here with the trunk. Maybe there's a VACL, right? All these layer 2 things to consider when we're taking a look at what the issue may be. So let's go ahead and clear that. So what we're going to do is, can we ping the default gateway? 192.168.20.1. So I can get to the default gateway. Well, if I can get to the default gateway, can I get beyond the default gateway? And beyond the default gateway would be router 1 across this link here. Excuse me. So let's pull router 1 up. Whoops. Excuse me. And I'm hoping that it's not going to be doing what sometimes happens with the simulators, and that is sort of doubling the whatever I type. You can see it put EENN instead of EN. And so we may have to reboot this node as soon as it comes back. And we'll give it a second here. And hopefully this is going to come back quickly. And I apologize if this does this and then only whoops. All right, so here's what we're going to do. We are going to manage devices. We're going to come to router 1, and we are going to, yeah, and it looks like it's going to double up. So we're going to go to manage devices here, and I'm actually going to reload the config on router 1 in the hopes that this will solve the problem. So there we go, console clear, disconnecting. And we are now back on router 1 here, and let's get, oh, and it's doubling it up again. And this is going to throw a wrench in this activity if we cannot get onto router 1. So let me power cycle router 1 and see if that helps. And what we may need to do is I may even need to go out and come back and reset the configurations from scratch. All right, so we're back on router 1, and now it's giving me 3 E's. All right, so I'm going to pause here real quickly. I'm going to reset this entire activity and bring us back to this point right here. All right, so router 1 is now cooperating. I had to jump out of the activity there. Let's get PC2 back up here. Let's hope we don't see that issue again. Let me get the access layer 1 switch up. And let's bring up the DSW1, the distro layer switch here. All right, there we go. So again, let's fix that first initial problem, which was show run interface Ethernet 00. And so you can see we're back to scratch here, but this will be quick, Ethernet 00. And it's going to be switch port trunk, allowed VLAN add, and VLAN 10 needs to be added. All right, so at that point, PC1 should get its IP address. Let's make sure we're good here. Show IP interface brief. Hasn't picked it up yet, but it should here shortly. And then we'll move on. And PC2 is good. Whoops, router 1, PC1. So no IP yet, but it will pick up its IP here shortly. So we'll let that work its course. So again, we're looking at PC2, and we had left off here at router 1, trying to get a determination as to what show IP interface brief. That interface is between the router 1 and distribution layer switch that we would be going to. So when we take a look at this here, it doesn't hurt to take a look at the job aids real quickly. And you can see Ethernet 02 is what we're interested in. So the IP there is 172.16.101. So can I reach the Ethernet 2 interface, right? I'm kind of following the path here, right? Or following the problem, seeing how far I can get. So 172.16.100.1. And I can make it all the way, pull the job aid back up here, I can make it all the way to the router. Let's see, can I go this way over to the server? We know that that's 172.16.210. So can I make it over to the server? So let's say ping, whoops. So we'll pull this back up and we'll say ping 172.16.200, oops, sorry, not 1200, 200.10. Can we get over there? So we can. But I can't get out this interface right here. I can't get out from router 1. So let's take a look at router 1. And let's see on that interface, show run interface Ethernet 01. And we take a look here, we can see description linked to the internet. We see the IP address, right, /30. And then we see IP NAT outside. So can I get to this 209.165.201? Let's check that out. Ping 209.165.200.1. So I can make it from PC2 all the way up to router 1, and specifically, I'm not having any issues getting all the way up right to that interface, right? So we've kind of been following the problem, right? Or tracing our path. We can get to here, but I cannot get over here. So let's look at that interface one more time and see if there's any clues on that interface that we should be keying in on. So when we take a look, you can see IP NAT outside. So we're doing NAT. Well, if we're doing NAT, we need to make sure that the NAT configuration is correct. So we could say show run section NAT. Right? We see we've got our IP NAT outside and IP NAT inside statements. We're going to confirm those. Default information originate. Right, and it's picking that up because NAT shows up in the middle of originate. And then we've got this IP NAT inside source list 1 interface Ethernet 1 overload. So syntactically, that is correct. So let's take a look at show run access list 1. Not show run, show access list 1. Well, we don't get any output back. Right? So this could be a problem. So first things first, let's make sure the inside and the outside interfaces are correct. So I get my job aid up here, and we take a look at the diagram. So my IP NAT outside should be Ethernet 01, and my IP NAT inside interfaces should be these two interfaces here, Ethernet 00, Ethernet 02. Right? These could be the inside interfaces. So let's check on, let's check on router 1 here, and let's see. Say, oops, sorry, show run. Well, I guess we could run through a show run here. So there's the DHCP, and that was working great for us now. We come down to the interfaces. All right, so you can see the link to the server, right? We're not doing IP NAT inside on that interface, but on the interface facing the LAN, right, we have IP NAT inside. So everything looks good on the link to DSW1. So now we're going to take a look at that ACL. And as we come down here, what do we see? That the IP NAT inside source list 1 interface Ethernet 01 overload is referencing access list 1. But what is the ACL that we've set up to match the inside VLANs that are facing our LAN PCs. It's access list 21. So we sort of methodically walked our way all the way to router 1, and now we see what the issue is. So there's two ways we could approach this. We could destroy access list 21 and redo it as access list 1, or we could simply remove the IP NAT inside source list command and then reissue the command with access list 21. And so let's do that. That's probably going to be less typing here. So we're going to say no IP NAT inside source list 1 interface Ethernet 01 overload. Right? So we'll get rid of that, and then we're going to reissue the command IP NAT inside source list 21, right? That's the ACL number that's set up for us. Interface Ethernet 01 overload. So we're actually doing port address translation, right? We're doing PAT or NAT overload, where all of these PCs on these two subnets here, both we're using, looks like /16s for both of those. They're all going to be using the single outside interface, and we're going to be using port address translation to handle the NATing. So NAT inside source list 21 interface Ethernet 01 overload, right? So we should have resolved, and what I could have said was do show IP NAT translations, actually. I could have said that, or do show IP, and let's actually end here, show IP NAT statistics. Right, you can see that we don't have anything going on yet, but we haven't generated any traffic. We wouldn't have seen anything with the previous setup because it was incorrect. So now let's come back down to PC2 and let's see. Can I still get to that inside interface on the router? And I can. So everything works great there. But where were we trying to get? We were trying to get to 209.165.202. And now that works. And so how can I confirm? Now I come back over here and I say show IP NAT statistics. You can see we have one translation, whereas before we had no translations. Now we have a single translation, which we would expect. It's dynamic. I could say show IP NAT translations, and there we go. ICMP, because we were using ping. The inside global, right? Remember, it's going to be the interface, and it's going to be the port that differentiates the connection. And so we're using the 1024 as the port. We've got our inside local IP, which is the IP for PC2, and then you can see the outside local and outside global addresses. All right, so it looks like this trouble ticket is taken care of. I should also be able to come to PC1, right? We should be able to ping from PC1 to 209.165.200.2. And this should work, and we should be able to see, if I were to say show IP NAT translations. Do we see anything from PC1? We're not seeing anything from PC1. And I'm sorry, we are. It is 10.2. My apologies. It is 10.2. It was 20.2 for PC2, and that's timed out. So we are seeing PC1 here. I was looking for 1 there, but I realize it's the default gateway. So it is working, right? So that trouble ticket is solved. So let's come over to our scenario. Let's take a look at the next ticket for the day. So Carol, the user on PC3, cannot use SSH to connect to the server at 172.16.210. So I've already got that written down. So she's on PC3. So again, let's come over to PC3. One of the popular ways to start is let's divide and conquer, right? Let's quickly see if we can eliminate specific OSI layers to focus our troubleshooting on the correct layer. So can I ping 172.16.200.10? So unrecognized host or address or protocol not running. So we've seen this before, right? We saw this on PC1. So let's say show IP interface brief. So we do the divide and conquer, and what do we see? We see that the problem is most likely going to be at layer 2 because we're not getting the DHCP address. But we do see what? We see that the interfaces are up, right? So everything looks good here on the PC. So now we started with divide and conquer. Let's go ahead and follow the problem, right? So we think that now we're going to step up to this next device, ASW2, And let's see with a quick show IP interface. And I think it's I did a show run earlier, but if I were to say show IP interface, and I thought it was, we'll say brief. And actually, brief is going to show me what we're looking for, but a quicker way to see this, I thought it was show IP interface status. Let me double check that. I swear that that is the command, show IP interface status. That's not it. What? Show interface status. I threw show interface status. That's what I'm sorry. Had that IP in there and was typing the command wrong. I was thinking show IP interface brief when I wanted to say show interface status. This is another quick way to take a look at the connections here, right? So what's our status? The status is disabled here on Ethernet 0, 1. And that goes to PC3. So if I were to say show IP interface brief now, right? Take a look at Ethernet 0, 1. Why is it disabled? Well, it shows that it's administratively down. So that's a problem. The port has been shut down. So let's confirm that. Show run interface Ethernet 0, 1. And what do we see? Yeah, we've got the shutdown command here. That's going to be a problem. So let's confirm, we've already confirmed that it's shut down, so now let's bring that port up. Interface Ethernet 0, 1, and we're going to say no shut. So now let's step back over here to PC3, and let's see, show IP interface brief. We should be picking up an address here, and let's see if that's the case. If it's not, we're going to have to continue the troubleshooting to see what the problem might be. And let me do this. Let's go into global config, see if I can speed this up by saying shut. So we're going to shut down the port on the PC, PC3. And then I'm going to say no shut in the hopes that I'm going to generate a DHCP discover. We're going to get an offer back. Okay, the interface is up. And then we're going to request it. And then accept. And so there we go. So now we have an IP. So can I ping my default gateway? 192.168.10.1. So do we have connectivity? We do. So can I get all the way over to 172.16.200.10? So I can ping it, but now the big challenge, can I SSH? And I think it was admin was the user, and this doesn't tell us here. So I think it's our job aids. We want to see, where's that information at? User ID is CCNP, and the password is Cisco, C1 capital S C0. Let's see if I can remember that. So SSH minus L CCNP over to 172.16.200.10, and we immediately get prompted with the C1 capital S CO, and there we go. So that has resolved this ticket, right? The fact that the access port on access switch 2 was shut down, that was the problem. So now we're going to get to the final ticket. Now, in reading this description here, this should immediately scream out to you that maybe we want to start our troubleshooting, right? Maybe not a divide and conquer approach by jumping into the middle of the OSI stack, but maybe we want to compare and contrast, right? Or spot the difference. Because let's read this description, right? So the user says, user on PC4 says he wants to access the internet through IPv6. He adds that because Andrew has access, so should he. Use IPv6 address 2000, and I'm definitely going to write that down, 2001 DB8 Delta 1 colon Alpha 5, and they make it extremely difficult here, colon 2. All right, so we've got that written down. So, and again, the reason I'm saying maybe it's a compare and contrast or spot the differences is they're saying that this other guy, Andrew, that he's not having any issues. And we know up here that what PC is Andrew on? Yeah, he's on PC2, so he's not having any problems. But the user on PC4 is. So let's go ahead, let's get PC4 up. And let's see what we've got here. Let's get into privilege exec. We're going to say show IPv6 interface brief. So what do we see here with the show IPv6 interface brief? And then let's even do a show run interface Ethernet 00. So we see IPv6 enable command is here. The IPv4, which we're not interested in, we're getting the address via DHCP, but with IPv6, we have IPv6 enable, and what kind of an address do we have? Yeah, remember, the IPv6 enable command is not going to get me or assign me a global unicast IPv6 address. IPv6 enable is simply going to slam a link local address on there. So now here is where the not divide and conquer, I'm sorry, the spot the differences, compare and contrast comes in handy, because apparently Andrew over here on PC2, he's not having any issues. So let's say show IPv6 interface brief. And here we go. Spot the difference. What difference do you see? Right? We see that the difference between Andrew's PC, PC2, and I forgot the other guy's name already. Let's say Bob's PC, PC4, is that there is no global unicast address on PC4. So let's take the compare and contrast one step further. Let's see, how is his interface configured? Aha! So he doesn't have IPv6 enable, he has IPv6 address autoconfig. So remember the difference between those two IPv6 commands. That IPv6 enable is just going to kick IPv6 off on that interface, and it's going to give me a link local address. But the IPv6 address autoconfig, and they're both going to use EUI64, and we can tell from that, you can see it right there, right? That FFFE, that's going to get me a global unicast address. And so let's go over to PC4 and let's make that change. Let's get into global config, interface Ethernet 00. We're going to say no IPv6 enable, because remember, the IPv6 address autoconfig, we're not going to do default for the default route, but we're going to say IPv6 address autoconfig. This is going to get me a global unicast address based off of the router advertisement that's being sent, right, from probably, is it going to be DSW1 in this case? Let's take a look. Show IPv6 interface brief. And in the VLANs, yeah. So in the VLANs, we have these global unicast addresses set up. So based off the router advertisement that we're receiving, we're going to take that router advertisement, and that's what we're going to use. And if we look at PC2, where is his address at? You can see right here, 2001 DB8 14:0. So if I come back over to the distribution layer switch, what do we have here? 2001 DB8, oops, sorry, I'm in the wrong VLAN. 2001 DB8:14, and that colon. Remember, we've got zeros that are in there. So we're taking the first, remember, we've got 16 bits, 16 bits, 16 bits, and then 16 bits. So the first 64 bits, right, for the sort of the network portion of the address, before we get down to the actual host portion of the address. So we're going to take those bits, right, and we're going to use those with EUI64, which EUI64 says we take the MAC address and we use that to come up with sort of the host portion of the address. So let's go ahead on PC4. Let's get back over here, say IPv6 address autoconfig. Right now, we could have used divide and conquer. I could have started out with a ping, but we already know the ping isn't working. And then when we read carefully, do show IPv6 interface brief. When we read carefully the description as to what's going on, and there you go. So we pick up the global prefix portion of the address here, and then we've got the host portion here, guaranteed to be unique, because MAC addresses are supposed to be globally unique. So that's why we use those MAC addresses. So now, from PC4, can I ping, and I'm glad I wrote this one down, 2001-DB8:Delta1:A5:Charlie8::2. Do we have connectivity out? And we do. Take a look at that, right? So that resolves trouble ticket 4. So real quickly to recap, the first trouble ticket we looked at, we started with divide and conquer because we didn't have much information other than, hey, PC1 can't get to here, to this destination. Same thing with the PC2 problem. We started with divide and conquer. And in both cases, we kind of had to downshift to layer 1, layer 2, and start from there. With Carol, she couldn't SSH to the server. So we did a divide and conquer. And again, we kind of interweaved and changed gears multiple times where we were like, hey, what about a spot the differences? What's different between, this guy's PC that does work and this other guy's PC that doesn't work? And that was kind of with the last one where they told us, hey, PC2 works great, PC4 not so much. So that kind of begs the question, well, maybe something's configured differently on those two PCs, and we quickly saw what that was. All right, guys, well, this is going to wrap up Challenge 1. It's the SECHNIK 1 use case. And hopefully this has sort of given you a good idea as to the process that you should be looking to follow and how that process can really help you out when you're troubleshooting, especially when you're not given a lot of information. All right, thanks for watching, and I will see you guys Thursday night.